So Cloud Volumes is available right now in both AWS and Azure. I'm going to demo the AWS version, and I'm going to show you a couple of screenshots from the Azure version. Both are well, Azure is in private preview right now, and we're going into public preview in May. And that means that we're going to accept more customers. Right now, we've been basically having companies, small and large, kick the tires, try it, run difficult workloads on it, run small workloads on it. Let's see what happens. And we've been learning from that and figuring out sort of where we go with the service in the near future. On AWS, because that's really our service and controlled completely by us, we are doing a more of a continuous release. So that service gets updated quite often, and not necessarily rolled out in sort of private public preview GA timeframes. So first of all, I log into AWS, and you probably saw I pasted a marketplace link there. And this is a hidden or private marketplace page since we're in private preview, but I wanted to show it to you anyway, because similar to any other service in AWS, you sign up to it through Marketplace. You sign up to it by clicking subscribe. It doesn't cost anything. You can start using the service right away. So I'm going to go ahead and do that. Now that I've subscribed, that's it. We've notified NetApp that you subscribed to it. And then when I click this link here, if this was the first time I subscribed, it would just forward me directly. I'm going to be taken to what we call Cloud Central. Now, Cloud Central is where we unify all of our APIs, but it's also where we unify all of our cloud services. And right now, there's only a handful of services in there, but this is where we're going to be rolling out the next version of Cloud Volumes, the multi-cloud stuff, the app orchestration, and a number of other things. So I'm going to log in here. And this uses a single sign-on. So if you have different services, they might have their own site to it and their own console, but you get the idea, like single sign-on. The single sign-on actually works with the NetApp single sign-on. So if you're already a customer, we'll, know you don't have to register. We just let you in. But we're definitely, want you to register if you're a new customer and give us a little bit of information about yourself.
Sorry, do you accept federated log logs from EFS or?
So, if you want a technical detail, we're using Auth0. So effectively, we could federate with pretty much anything.
Okay.
But right now, it's basically, the NetApp SSO and a registration. So when you create an account here, that becomes your master account. And what you see here is the UI for Cloud Volumes only. So if I wanted to do, for example, Cloud Sync, I have an option here on the side to jump between these different services. All right. So what I'm going to do now, I'm going to create something like a 10 terabyte volume. There's a 100 terabyte limit on the size of the volume now, but we're working towards multi-petabyte per volume. I don't think.
What's imposing the limit? Is it something with the provider? Is it software?
No. It's just we just decided to. It's a virtual limit that we decided to start with, and it has really. It's because of how we architect it in the background, on the back end, versus rather than roll out like hundreds of petabytes right away, we want to roll through public preview and up to GA on these limitations.
So it's more of a gated limit.
It's a gated limit, yeah.
Okay.
So now I subscribed, I logged in. I'm going to go ahead and create a 10 terabyte volume. So I'll just call this machine learning. I give it a name. It's going to generate a unique volume path for me. I can change that to pretty much anything. Kick-ass elated gates, or hungry condescending bullheart. You might sort of find these.
Doesn't sound Nordic or Nordic at all.
gloomy, trusting Wozniak. I like
Sounds
that.
about right.
Yeah.
Yeah, so you might recognize these from like the Docker world, right? These are famous scientists and authors, combined with some fun adjectives. Anyway, the reason why we do that is that you want each volume to have a unique path, but you also want it to be humanly understandable, because you don't want to have like a volume that's called 32 letters and dashes. Like, how are you going to communicate that? So better UX here. Anyway, in my account, I only have access to AWS. But here you can see I can select AWS as the region. And this is just in a single region right now. I can also select the time zone. That's kind of the reason why you might want to do that is because when you set snapshots and backups and that sort of thing, you might be thinking like, I want to make backups in the time zone of the customer, not where it's stored. You'll see that I can create a volume directly from a snapshot. This could be from any volume that I've created before, not necessarily from this one, or not. If I wanted to actually revert, I can do that as well. And I can select a service level. If you saw it before, basically in the private preview, we are running at a premium service level, and they're called different things between the cloud providers. But that equates to roughly about 3,000 IOPS per terabyte. I can set the quota here. This is really just the size. I'm not going to do exactly 10 terabytes. I'm just going to wing it here. It should be like that. And the second thing I have to set here, actually don't need to change, but what I can do here is actually configure the volume for what protocol I wanted to expose. And this is actually a multi-protocol select. So I can have a volume that's NFS and CIFS at the same time, which is a huge benefit if you're running both Windows workloads and Linux workloads at the same time. For the AWS service, we've only opened up for NFS, but this is kind of like an Ingress rule as well. So here I can add an additional security measure saying like, I only want this instance or this IP or this host name to be able to talk to the volume. This is in addition to what the cloud provider can give you. And then lastly, because we're all about automation, I can actually tell it to create a snapshot policy for this volume right away so that I don't have to manually do that. And this is something that happens asynchronously, meaning that this is happening all the time, and it will let me know, the service will let me know if something goes wrong or if it goes right. Essentially, I can do things like keep 2 snapshots. You can see the explanation here is updating dynamically. So it says keep snapshot every hour on minute 53 and keep 2. So I put 53 because it's 52 now. So I'm going to see if I can create a volume that automatically makes a snapshot of itself.
So while it's doing that, one of the things I
done.
keep thinking about. Okay, it's done.
Sorry.
My question.
Go ahead.
No, it's still creating.
Yeah.
So it's setting the network. It's creating the network path. So this runs in the VPC.
And now it's available.
Yes.
Darn it. So one of the challenges that I commonly see is, this is great in a vacuum, but the reality is with cloud you have Ingress and Egress charges, right? The data transfer charges.
Yeah. Not here.
You don't have.
Well, this wouldn't happen if it's all contained within cloud. You wouldn't have it. But what if I'm kind of going back to that bi-directional connection between something you might have on-prem versus leveraging cloud for storage.
Right.
Or
so the cloud.
where
You're
there's
right. I
some
mean, the
connection
cloud
between them.
provider might impose some egress charges. There are no ingress charges. So I can stream this.
No
I can stream
ingress.
data. I can stream data to the cloud, into cloud volumes.
But the egress charges make up for the difference.
Yeah.
mean,
Well,
in a lot of
that
ways.
depends if you're going out of the cloud or not.
Right.
I mean, not everything will go back and forth, right?
But
How does
that's
that differ for any other cloud
No,
storage?
it doesn't. I'm just wondering if there's maybe something that starts to limit the amount, get
Yeah.
smarter about the data that gets transferred,
Yeah.
such that you can limit those charges.
Yeah, and to be clear, I mean,
Right.
the amounts of data, some of it you wouldn't just try and push those bits over the pipe. Like we definitely are. I have no idea if we announced it or not, but we're definitely thinking about like a snowball type situation where you can take a box and basically ship it to cloud volumes. So-
When we were talking with NetApp, I mean, this was a couple years ago at least, where we started talking about data fabric. At the time, the idea was that there'd be an ONTAP for cloud instance running in a non-Amazon or non-Azure data center, but they had a high bandwidth connection to an Amazon or an Azure data center, and that would allow customers to avoid egress fees so that they wouldn't have to worry about what they're doing with their data. Is that service still available and this is replacing it, or is this a new service that's going to be offered alongside that?
I'm not familiar with that
NetApp
service
private storage
at
you're
all.
talking about.
Yeah.
Yeah.
Is that
Are you talking about NPS?
NPS he's talking about.
So NetApp private storage. So that's still a service that's available.
Okay. This is not replacing that.
No.
Okay.
could augment it. That
Yeah.
to the point of all this, that whole network egress charge thing really breaks the multi-cloud thing,
Yeah.
which for all of the cloud providers is like, hell yes, I'm going to dig a moat because I don't want, Amazon absolutely doesn't want you to leave, and Azure doesn't want you to leave either.
I don't think it does, because if you're using SnapMirror to replicate the data,
Yeah.
whatever you update when you're in the cloud is going to be the delta changes that you then will pull out, because SnapMirror will
Yep.
keep the sync between the two. So
Right.
it might not be as bad as you think.
Well, the first set of data that you replicate, you've got to be
Well,
careful.
you've got to put, but that's only going in, isn't it? So that's fine.
Well, what you're
No,
saying,
because
what
if
you're
it's in
saying
one
is
cloud
take
to the
two-
other cloud,
take two
it's egress
copies,
from one
send
of
it to each of the two. Take two providers, send the initial load to each of the two providers, and then that way
and
the
then
only
just
thing
do
that ever goes
deltas, yeah.
between are
the things that you've changed. So if you don't change
Yeah.
very much,
Yeah.
you've only got a very small.
The only
packet.
problem with that is if you start creating data in one of the
Absolutely,
cloud
then you've got a
providers.
different scenario. Yes, if it's all unique data being created, then you're going to have to push that across.
And
across
that's
cloud.
the whole. You kind of already had this issue already. Like if I create data in a data center here, and I've got another one on the other side of the planet, moving that over a network takes a long time.
Yep.
But it is possible. So, and if I've already, like if I'm leasing, like if I buy the line, I don't pay for each bit that runs over the line. I pay for 10 gigabit
Yep.
network connection, and I just pay for 10 gigabit.
So I think
Whereas
you
this, I get
make
to pay
great
for 10
points
bit.
there, and like
Yeah.
I think the key there is how do we drive down that cost, because the cloud provider is going to set a lot of the rules on there. Like everybody's going to have to play by their egress rules, right?
Yeah.
So how can we minimize that? And you made a great point with using something like the protocol for SnapMirror is going to help you with like dedupe. You're not going to be transferring all that data, but just the changes. There are other options like cloud backup, which will have deduped and encrypted archives in something like S3 from any one of these data points, whether it's on-prem, cloud volumes, or somewhere else. And those also take up much less and cheaper than doing the pure sort of file-based copy.
They do. It's just the prospect of a data fabric where I have my data wherever I want it to be
Yep.
gets killed by this egress thing because I have to be careful about where my data is because of egress. So I can't just have all of my data everywhere
So you can't,
unless I want to pay a lot of money for it.
so there's the egress charges, and I've debated this for a long time. Do I want my data everywhere? Or do I want my metadata of my data everywhere? And then on access, pay the egress to have the data transported with some delay. Is the real use case for most of these multi-cloud solutions to have the bits and pieces about what data do I have in the enterprise, or is it literally that I have to have my data everywhere? And it's a tough challenge.
No, I actually don't. I think it's more poignant than that. I don't think you can answer that question in a vacuum, period.
True.
I think you have to understand what is the application, how is the user interacting with the application, where does the data need to be able to support that application, and then that starts to govern your options in terms of how you manage the underlying data set.
When I think of data fabric,
just real quick, the last piece to that is, I do think as you start to move into a cloud-based world, you can't bring those traditional ways of managing data forward.
So I agree. So thinking at this from a large enterprise and being a service provider to internal customers, one customer will have one set of requirements, another one will have another depending on application. What I can level set and say is that I would love to have my data everywhere so that I can serve each individual client as needed, and I could turn knobs to say, okay, in this region of the world, I have 2 petabytes of storage, and I'll replicate data as needed. In this other part of the world, I have 1 terabyte of cache, or whatever the solution is. But the key is, and I think this is one of the gaps I see in NetApp's data fabric vision, is I don't see how you guys are facilitating that metadata conversation of how do I solve the problem of knowing where my data is in the world and what data is it? Yep. And that is, I think, a key to part of becoming a data company.
And I can tell you with high confidence that is exactly where we're going.
Yeah. It's more than just managing the bits.
Yeah. And managing the bits is one thing. Getting to the right applications, getting to the right compute, getting to the right services that offer you new value from your existing data is the important part that we need to solve first.
Yeah.
Regarding the egress site, it depends on where the data is. If the data is centrally located at the customer's place and there's no ingress charges, effectively he can send it to all of the cloud volume services that he can find and pay nothing for that, right? So it only happens when you're talking about egress between cloud providers, because within cloud providers, the egress depends on region, zone. Like there's a ton of things to think about there. All right, I'll get back on track. Sorry for that. But I like the conversation, and I hope we can continue that later on. So I made a volume. Great. Took probably about 10 seconds. Doing this with any type of service that's out there today would take me probably hours, if not days, to get set up. And now I want to actually use it. So I'm going to mount this volume here in an EC2 instance. So let's go back real quick here. Just so you see me go all the way through. Log here into EC2 and instances, demo, and here's my IP address. Now let me just put this here side by side so you see how easy that is. So clear this, SSH. So I'm gonna just log into this Ubuntu server. Running in US West 1, I'm in. Since NFS, I'm going to use NFS as the protocol. So since that is something that you need to use sudo for here, I'm logged in as sudo. So I'm a root user now. So you can see there's nothing there. So if I was doing this from scratch, what I need to do now is copy that command, paste, copy that command, paste. Now, based on the level of performance that I selected, we would show you different mount commands for this, optimized for the workload that you're trying to do. So this might be, for example, high performance database that I'm going to use this for. So copy that, enter, and my volume is ready for consumption. And you can, like, for those who know something about NetApp and have seen NetApp volumes before and NFS shares, you'll notice the telltale .snapshot folder there. And the cool thing about that is snapshots within NetApp within ONTAP. They're such a cool thing for everything from development to making your applications way faster, to replicating big data sets, bringing them to everybody at once, making a development environment from a production system. There's so many usable things you can do with this because it's instant, right? It's not a backup. Many people might think Snapshot is backup. It's not a backup. There's another service for that. But Snapshot is something like like Time Machine on your Mac. You can go back in time, or you can create something new from that particular day or hour that you made that snapshot. So let's see if there's something in there. Right. So you remember I set the automation to make a snapshot 53 minutes past the hour, right? So now that I've done that, instead of just restoring, making a snapshot and then creating a whole new volume from that, maybe I just need one file. So if I wanted one file from that, I can simply go ahead and copy a file from within the snapshot. Because the snapshot itself is really just a file structure. So that makes it even more capable of helping out operations, helping out development in getting back to that state where everything was fine, or maybe I just want to try that test one more time with the script that I had, or maybe I need to, maybe my Hadoop process failed on that node and I want to restart the job on that node so I can go back to that. Now, I'm going to talk a little bit later about how to get data to that, but let's continue.
Can I ask a question?
Yep.
Call me cynical, but
We do.
how is this just not putting a storage array on in an AWS data center and putting a nice UI around it?
How is
Really
it not?
struggling to see where this is innovative and doing something that's new.
Right. So, good question. It is and is not a storage array in a public cloud. What's really new here is that you have not been able to consume file-based storage at this performance level and API-driven at all in public clouds. That means that some applications, not just enterprise applications,
Could not live there.
that couldn't be there before, right? So that's kind of the big thing. And what you could have done before was, stand up ONTAP Cloud, launch that appliance, but you need a NetApp guy. You need somebody that knows how to set that up, knows how to configure it and all of that, just to get to that point where you can get shared multi-write, multi-read storage.
And that would be possibly subpar for performance because it's just
Absolutely
a virtual machine.
subpar for performance.
Where this is native.
Yes.
Yeah.
I think there's one other bit as well, which you haven't touched on yet, but you might be going into here, and that's if you look at the way you provision an instance or whatever, you get to select where the storage is going to sit, and you connect it through the actual APIs and the GUI directly. With this, the storage is like a first level feature you can add to an instance or a VM. It's not separate from. It's not like in a VM and separate, which means any functions that you use on that VM, like snapshotting or other things, can be driven by the standard platform APIs, and it will directly talk to the storage as well. So it doesn't have to be done as a separate task. So the two become much more closely integrated. And I'm not sure whether that's what you intend to show as part of this? Because
Well,
it's more integrated.
as far as like integration, you saw AWS. That's our service. It's completely our service. It's running, next to Amazon, like in each region right now, with direct connection, versus the Microsoft version of that, which is, part of Azure. Like this is a service that's part of Azure. So you can find it in the marketplace. You create it. You can. I'm just showing you the UI, obviously, because it's hard to show visual nice things to a large crowd with command line and APIs. So the same thing I just did with AWS, I can do on Azure, but behind all of those subscription rules, my Active Directory access, all of the things that make Azure natively. So here we got multiple volumes in different resource groups. Might be in different regions here. Some of them are large, some are small. But the same thing applies. Like it's as easy to use in Azure as it is in AWS, and will be in other providers as well.
Would you see that then turn up in your cloud volumes in the NetApp cloud portal you're in before?
Yes, eventually. We haven't opened that up yet.
So for
But
AWS,
eventually, yes.
that turns up at the moment.
If you choose to, because you need to essentially like allow us that access so we can, combine the two. And that's where the Auth0 thing comes in, where you essentially federate the API calls.
For the Azure piece.
Yes.
Yeah. So the AWS, you have to do it in there because you don't.
Yes.
Yeah.
Yeah.
What about, can you tell us the differences between what an NFS share and an SMB3 share will be from within the NetApp cloud volume context? Is there any kind of...
Really no, well, NFS v3 versus CIVs, they're obviously a big difference. I mean, you want to have CIVs for speed and performance and compliancy with Windows. That's pretty much what you're using it for. SMB obviously can be used in Linux and all that, but that's your go-to protocol for the Windows workloads. On the NFS side, NFS 3 is really unauthenticated, so it's really behind the networking security that you have here. When you start a cloud volume, you are using it over a private IP, and only the VPC, if I talk like in AWS terms, only the VPC has access to that. Okay. Only your VPC. And that's protected all the way to the volume, even though this is a multi-tenant service. And the reason why we can do that is because of the software-based networking that's built into ONTAP and NetApp boxes, and the way that AWS and Azure they structure their networking security. Now, having said that, you want to be able to use these things equally wherever they are, right? I mean, I'm not going to focus more on that here, but essentially what we're doing now is just bringing the services to people where they are. So if they're in Azure, they want to use this in Azure. If they're in AWS, they're going to use it in AWS. And I compiled a few use cases for this, and I'll just let you look at it for a little while. LOB, line of business. So think about specific applications that matter to the company. We've got some buyers there, the key concerns, and you can see like in all those categories, or most of them at least, you're thinking about performance. They're thinking about real integration with the cloud provider. That's important. As developers, and we haven't been playing in that field before, I would say, like application developers are really going to like this, and I'll show you in a few minutes why I think they'll like it. But it's important to realize that like NetApp is used all over the world today to speed up things like continuous integration, continuous development, like build servers. Like that's where we've been playing. We haven't been playing in the public cloud doing that, but with like NetApp's plugin for Jenkins, it makes builds way faster. We've been playing internally with like Hadoop. With Hadoop and Cloud Volumes, way faster, uses less resources. Like there are very, very interesting use cases here that we'll talk about more when we can sort of talk about the customers that are using Cloud Volumes now. But we see a broad spectrum of buyers for this service, and I can tell you that the sort of interest in trying out Cloud Volumes on the different hyperscalers has been really, really high. So we are trying our hardest to actually put these services out in a public way as soon as we can. But as you can imagine, there's only a certain amount of hours in the day. So we're trying to get there as fast as we can.
Can you go over some more developer-oriented use cases?
Yes. So there are a number of ways that you would consume Cloud Volumes as a developer. One of the ways is NetApp has created a Docker plugin called Trident. And what Trident does on premise is that it automatically creates the internals that you need to be able to create volumes. So in NetApp speak, there's something called an SVM that's like a container, storage container for the volumes that you can create on top of that, right? So Trident, it's like a controller or like an engine for things like Kubernetes that automatically creates those volumes for you when you describe your application. So Trident will, for Cloud Volumes, do the same in the public cloud as it does on-prem. So we'll be able to deploy applications and automatically create persistent volumes based on the profile the user wants for the application. So if he's building a high-performance database-based application, he might choose the extreme level for Cloud Volumes just for the database. But you might use EBS, or you might use something slow for the application layer or the presentation layer of the application. Does that answer your question?
Yeah.
All right.
So is this, I'm just trying to kind of wrap my head around this, and
Yep.
I'm not as sophisticated as other people in the room, but I guess what I'm thinking about is this really a story where the core storage offering from an Amazon or Microsoft, so Amazon Cloud versus an Azure Cloud,
Yep.
is almost too basic of a building block, and so what's missing is that almost like a layer between it and where the application or where the developer really needs to tie into.
It's
more refined. I guess what I'm really getting at is, are we missing that refinement of the AWS and Azure storage building blocks? And that's really the problem that this is solving, is providing a much more refined way with some management in there too.
It's that, and it's actually like a number of factors. I like it how you put that, but it's actually a number of factors. It's the ability to do shared files, multi-read, multi-write, that just not available today, right? EFS. I'll show you why you don't want to use that versus Cloud Volumes. So it's a new feature that hasn't been available before, and people have been working around it like crazy. Like you create all of these, all of these schedulers and stuff around storage to get around the problem that you can't just point things at the same storage. Like it creates new DevOps problems to solve when we can just bring this to the table, and then you don't have to think about that. Like it brings a new thing and it also brings new features like just the instant snapshot and clone. It makes a huge difference in multiple applications. Like I'll give you an example, like in development, you have a build server and you're building an artifact. You're basically doing like a full build of your application. With NetApp and some plugins for something like Jenkins or GitLab or whatever you want to use, you can actually create a point in time with a snapshot that you can build on top of. So you don't have to start from scratch, right? And when you build an artifact and it's finished, you can snapshot it, and then you can instantly grab that and create a new volume for it just for that build process if you want to, and make the whole thing way quicker. So, and using replication between sites, if you've got distributed development teams, there's a whole lot of things you can do with this that you could not do before.
So
I guess where I'm going with this was more of, we never had this problem with the on-prem structure. But this problem now exists because on-prem, you're never writing directly to a drive. You're writing to an NFS volume, right? Or a CIFS volume.
Yeah, or ISPSE block.
That becomes that kind of interlayer that's missing in the traditional cloud offerings.
Because it's super hard to do. Believe me, that is the reason why it isn't there. And underneath a lot of these services, at least from like maybe the smaller public clouds and all that, they actually are using this. Like they're using NetApp, they're using NFS underneath their thinly provisioned volumes and all of that. They're not exposing it to the end users because it's hard. I mean, it's very hard to build. It's hard to maintain. Like we've, as a company, and say we, because I've obviously been sipping the Kool-Aid here for 8 months, we have figured that out a long time ago. And that's interesting part of, like now we can actually bring that to the table. And I think there's a lot of new applications and different ways of architecting big applications that we're going to see.
Yeah, I'm trying to figure out that it creates a new role in cloud DevOps that kind of didn't exist. A new role or not necessarily a new role, but a new opportunity to provide a centralized within whether it's a PaaS or a development platform, a new layer of data services from a DevOps perspective, building more capability. I like your build process. That was a great example around just shared, something simple that we've had in enterprise for 35 years or more.
True.
Bringing it to cloud and giving it cloud scale is really interesting.
Yeah, and I'd like to show you guys a little bit on sort of where we can help. This is not a scientific test. I just wanted to show you because we were talking about EFS before. This is just a FIO test, which tests random read, random write. It took Cloud Volumes 52 seconds to finish this. It took EFS 16 and a half minutes. I thought this might be a fluke. Let's try it out. Like I say, I'm not really a storage guy. I'm a developer. I like optimized things, performance. I want things to run smoothly. So I thought let's try it with against an SSD, a local SSD or an EBS SSD on an extra large instance. Here I'm using SSD on an M3 2x large, and Cloud Volumes was 10 times faster to complete the random read, random write. So not only, and by the way, if you put 1 terabyte on Cloud Volumes versus 1 terabyte of provisioned IOPS SSDs on AWS, Cloud Volumes is still cheaper.
Is that using an EBS optimized instance? Provisioned IOPS?
It's a high optimized, I can't remember if it's optimized storage or optimized compute, but it's high network. And that's just the general, what's it called? The general purpose SSD.
Yeah, so it's not.
And on the cost side, when I did that cost comparison, I just took 3,000 IOPS, 8 terabyte, and compared the cost of provisioned IOPS SSD, which is their most expensive and fastest version, versus the
general purpose
versus Cloud Volumes. I forget the service level, the premium service level.
I'm just curious about the architecture that sits behind Cloud Volumes.
Yep.
Is that using AWS primitives to build the Cloud Volume service?
It's a giant black box. I can't tell you that.
You're not allowed to tell us.
No.
How is that presented
Well, can I ask a
networking
stupid
wise?
question?
Go ahead.
Why is cloud volumes cheaper? Now, I think that might lead to be that I don't. I mean, I look at it and I look at the standard service that probably doesn't use stuff that's as performant as what you're using. Amazon's keeping all the margin there, right?
Yep.
I assume that with cloud volumes, there's something going to Amazon, something going to NetApp. Why is it cheaper?
How do you compete? Like, we are new to this game. We need to compete. We need to make a service that's highly available, highly performant. So the trick here, and I don't think it's going to be a secret, but the trick here is that NetApp has a number of storage efficiencies that it can gain from like dedupe, compression, all that. To make the service cheaper.
Yeah, so it's the data services that run on top of it.
Right.
Okay,
Right.
got it. So
They're taking advantage of their own data
30
services.
cents a gig, is that
Yes,
effective?
per month.
Or is that
That is
raw?
That is what you would see if you do ls minus L in your Linux
Okay,
command.
so it's effective.
Yes.
So I'm paying 30 cents a gig on the, okay, so that's how it's.
Yes. However, so we are making the service cheaper by owning the efficiency that we gain from the multi-tenancy, right?
Right.
But you are gaining the instant snapshots and clones with the efficiency.
And so there is a risk to NetApp, though, and Amazon, I guess, maybe not as much with Amazon, that if you're storing stuff that has sucky, that's my word of the week, reduction capability, stuff that's already compressed or that's already that's not in good form, that you're going to end up not making much, if anything.
It has to be
For
the
some
snap.
users, yes.
It's going to have to balance out over the customer base.
Yep.
You're saying
Okay.
that NetApp isn't going to make anything.
I'm trying to.
On an individual customer,
Yeah,
let's
I know
say
it's not.
if an individual customer isn't using snapshots, but they're just storing like all images and they can't, all unique images,
Right.
they can't be compressed, can't be deduped, then
So I'll make kind of a bold statement and say, I think you kind of have to do that because at the end of the day, someone else is going to figure out a way around that. So why not just cut them off at the pass and just say, look, here's the reality. We're going to get there. Let's just get there. And all of these other pieces, and
I'm not saying it's bad. I just want to understand the business model.
Yep.
That's it.
Well, so, and I'll tell you,
it's Jevon's paradox, right? So
I don't know what that means.
You get the cost down.
I have a nephew named Javon.
you use it more, but lower the cost.
You lower the cost to the point that more people start to use it.
Oh, no, I get
And
it.
then more people start to use it,
And you
and
can
the
bring your cost
reality.
down on scale.
That's right.
Total volume
Understood.
goes up.
That's right.
Yeah.
Yep. One
Or
of my
you could
favorite
just do
paradoxes.
you could follow the Amazon model, which is just make sure you keep growing fast enough that as long as everyone keeps clapping, the fairy stays alive.
Yes. So another reason why, what I can say about the pricing, I'm glad you think it's too cheap. That's great.
Oh, I never said that.
Well, you have to think about maybe I wasn't clear enough in the beginning. When I say Amazon started with S3 and EC2, and you can build everything else on top of that, think of cloud volumes the same way. We're building the foundation for a ton of other services that add value and also create a lot more revenue for NetApp.
Just on data volumes, a couple of things.
Yep.
Can I mount, or is there an option in the future to mount a volume that I'm presenting into AWS also into Azure? Or, once the Azure service is...
From our perspective, you can do whatever you want. What you would need to do, and I'm not condoning it, is that you would need to open up a network.
But directly from your service, I can't do that. Where I'm seeing the app volume, the volumes in your cloud service.
So there's because it's a protocol, it's the same with EFS. You can mount EFS on your desktop at home. It's going to be terrible performance, but you can do it.
I'm just wondering about the egress and ingress things we were talking about. If actually, where I'm mounting that, the volume lives in NetApp, and I'm mounting that separately from each service.
So the volume on Cloud Volumes, it lives in each hyperscaler.
Yeah.
I can tell you that.
So you wouldn't be able to necessarily do that natively.
It's technically possible. I wouldn't.
But you'd be mounting it from AWS across
I would try it, but just out of curiosity. But yeah.
I noticed that the mount path, it was a private IP address.
Yes, always.
They're using VPC peering to create that connection. or do you have to reserve a block within your VPC to consume the cloud volume?
It's different between cloud providers. Some opt for peering, some opt for actually peered subnets. Not all of them support that, but so yes. The reason why I don't go like, oh, it's like this and this and this and this, not because it's a huge secret, but because it might change. Like right now we're in private preview. Some of it is running in like direct connect and on your own VLAN, but NetApp bears the cost of that, like for testing purposes. Some might actually like live in the data center and be right next to the other services. So I can't speak to like
is that IP address
which is which, but yeah.
Is that highly available? So say in the AWS,
yes,
it's that IP address. If I lose a AZ, that's still going to work in the other availability zones.
So it's the fault region, what do you call it? The fault region is the region. Like it's a regional based
like S3 or something. So
yes.
Yeah. Okay.
Yep.
So the actual implementation is spanning availability zones. So you can lose an AZ, still have connectivity, but you could lose the region.
Yeah. And you're making that IP address highly available as well. So so underneath you're doing a similar thing to S3. You're replicating that.
Yeah. So technically we're using features from NetApp that has sort of software based IP load balancing.
Yeah.
Internally.
Sure.
Cool.